All right, let's talk about 11.4 arcs and chords. Let's review what arcs are though. So in arc we have two different kinds. We have a major and a minor. So a major versus a minor. So in order to get arcs, we need to make some points on a circle. So to the left here I have a circle. Again, the dot in the center is the center. Again, to create arcs, I need 2 points on a circle. Connect those with the center. Those two green lines that I have are called my radii. My minor is that purple line. It's the smaller of the two arcs. And then my major is this blue one here. Just a review on some arcs. So again, this one is my minor. It's the smaller of the two, and this is my major arc. Okay, that's some recap before we start 11.4. Okay, so let's talk about 11.4. Arcs and chords. So theorem 11.4, if a diameter of a circle is perpendicular, again, we know perpendicular to be 90 degrees, right angle, okay? If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Again, bisect means to divide in half. We know what a chord is. A chord is a segment inside a circle that does not go through the center, but touches a circle twice inside. Okay, so this is basically saying that if I have my circle, which is on the right, if I have my diameter is BG in this case. If BG is the diameter, okay, and it's perpendicular to my chord in this case, DF is my chord. If they are perpendicular, then my diameter BG bisects my chord, so making these two parts congruent. So DE is congruent to EF. It also makes my two arcs congruent. So DG and GF are also congruent. So if BG is perpendicular to DF, then DE is congruent to EF, and arc DG is congruent to arc GF. Let's go down to example 1. So in circle C, the diameter AF is perpendicular to BD. Use the diagram to find the length of BD. Okay, because AF is a diameter that is perpendicular to my chord BD, you can use theorem 11.4 to conclude that AF bisects BD. So BE is actually congruent to or equal to ED, and we know ED is 5. Okay, want to find the measure of BD. So I need BE and ED. Well, they both equal 5, so I'm going to substitute 5 for both of them. So 5 and 5. Add them together, I get 10. So the length of BD is 10. Let's go down to checkpoint. So I want to find the length of the segment. So in this case, I want to find, in number 1, the length of JM. Well, I see that GK is a diameter, and it is perpendicular to HJ. So I know that GK is perpendicular to HJ. Because it's perpendicular, and because GK is a diameter, I know that HM is congruent to MJ. Okay. Again, because it's perpendicular and it's a diameter, it's going to bisect that chord. So HM is 12. Right now, I don't know what JM is or MJ. Either one doesn't matter. This is the same as this, just the letters are flipped, and that's okay. I'm going to flip it back around. Let's go JM. Okay. Well, because they are congruent, they are equal, so JM equals 12. All right, let's talk about the next one. So number 2, find the length of SR. SR is my entire chord. In number 1, I was just finding parts of my chord. Number 2, I'm finding the whole chord. So I know that PQ is my diameter, and in this case it is perpendicular because I see that right angle. It is perpendicular to SR. Because it's perpendicular to SR, I know that RN is congruent to NS. Okay, because they're congruent, Rn equals Ns, and they both equal 15. Well, I want to find the whole length of SR. Well, that is Rn plus Ns. Well, Rn is 15, Ns is 15. So SR equals, add them together, 30. Moving down to theorem 11.5. If one chord is a perpendicular bisector to another chord, then the first chord is a diameter. So if I know that JK is perpendicular to ML and MP is congruent to PL, then JK is my diameter. We're going to go all the way down to 11.6. In a circle, or in congruent circles, if two chords are congruent, then their corresponding minor arcs are congruent. Corresponding just means the same, essentially. Okay, or the same place, same position. So if two chords are congruent, then the corresponding minor arcs are congruent. If two minor arcs are congruent, then their corresponding chords are congruent. So in the picture that I have to the right, if AB is congruent to DC, which I do see in my picture, then my arcs AB, again, arcs are labeled with the little curled line on top. Arc AB is congruent to arc DC. So I know that this green arc is congruent to this green arc. And then if I flip them, or the converse of that, arc AB is congruent to arc DC, then I know that the segments AB is congruent to DC. Let's go down to example 3. So I want to find the value of x. Okay, so let's look at A. So because QP is congruent to RS, so I know that this line is congruent to this line, it follows that arc PQ is congruent to arc RS. So the measure of PQ is equal to the measure of RS, and we know the measure of RS, based on my central angle, is 60, so I know that x equals 60 degrees. Because this arc is 60, and my two sides are congruent, and that this arc and this have to be congruent. So they're both 60. All right, let's talk about B. So because arc AB and DE are congruent, okay, because they both equal 70 degrees. And my arcs are right here. Because they're both 70 degrees, it follows that my segments AB is congruent to segment DE. So AB equals DE, and because DE we know equals 3, we know that AB, or x, also equals 3. Let's try some problems all together. So I want to find the value of x. Let's talk about number 1. So for number 1, because I see that my central angles are congruent by those two parts I just circled, I know that my arcs are congruent. So I know that AB, my arc AB, is congruent to DE, my arc DE. Because my arcs are congruent, the segments are congruent. So AB is congruent to DE. Let's fill in what I know. Well, I know that AB is 4, and DE is x. Well, there we go. We got x equals 4. And I'm done. Let's talk about number 2. So here I see a 90-degree angle. Well, this diameter here is a line. A line we know is 180 degrees. Okay, if one side is 90, the other side also has to be 90. So I actually know that these two arcs are congruent. So I know that HG, my arc, is congruent to GF, my arc. Because the arcs are congruent, the segments are also congruent. So HG is congruent to GF. Again, note that my arcs are labeled with that curved line on top, and my segments are labeled with a straight line on top of my letters. Okay, just like this one and this one. Okay, let's start plugging in stuff. So HG I know is x plus 2, which equals GF, which is 5. Well, I want x by itself. Right now I don't have x by itself, so I got to get it by itself. Okay, well, how do I do that? Well, I subtract 2 on both sides. I get x to be 3. And then lastly, number 3. Okay, so I see that my two segments here are congruent. So VU is congruent to YZ. Okay, they are congruent because I see those two tick marks in there. That's how I can tell something is congruent. Okay. Well, because my segments are congruent, my arcs are also congruent. Excuse me. So I have VU arc is congruent to YZ, my arc. Well, my arcs are congruent to my central angle. Okay, my central angle in this case is 40 for VU, so this is 40, equals the central arc here, or central angle there is x plus 10, so I have x plus 10. Okay, well, I need x by itself to solve for x. I'm going to subtract 10 on both sides. I get 30 equals x. And then again, a way to check if your answer is correct, we'll plug it in. Do you get the same thing as you did for the other side? If you did, then you're good to go. My suggestion is you're checking every single answer to make sure you're doing it correctly. If you don't get the same answer on both sides, well, then something got lost along the way. Make sure we're checking our answers. This is how we solve for arcs and chords.